So we've already covered the addition of bromine to an alkene, which gives anti-addition of the bromine. Now we're going to cover the addition of bromine in the presence of water. Now this also gives anti-addition, like you see here. However, we get a alcohol at the second position, at the more substituted position, instead of a second bromine. And I'm going to walk you through the mechanism. We're going to explain why that is. So this starts off very similarly to how the addition of Br2 goes. Okay, we have our bromines bound to each other, and we have our electrons. And we're going to form that bromonium ion into Br minus. Remember, this bromonium ion, there's a 50-50 chance of it forming on a wedge versus a dash. I just like drawing the wedges, but it can also form on the dash as well. So we have our bromonium ion. And now, if we were just doing Br2 addition, this is where our Br minus would come and add. However, we are running this in water. And so what happens is water comes in, and that's what attacks at the most substituted position. And if you remember from the video about Br2 addition, this attacks at the most substituted position because this one has the most carbocation characters, most primed for that attack. And if you're wondering why, go back and check that video out. So what we're going to get is we're going to get an intermediate that looks like this. Remember, this is anti. We push this away. So we have our bromine down here. Now we have an H2O plus. And then we can either show another water molecule taking this and kicking the electrons up here, or we can show our Br minus taking it. Both are mechanistically valid. Likely, it's another water molecule. And that's what gets us our anti-addition, where we have this alcohol at our most substituted position. And now you might be asking yourself, well, why doesn't the bromine just add back? It's just right there. Well, it's right there in the context of our board. But in real life, this goes off and just does other stuff. Even if it did just sit right there, what's going to happen is going to immediately be solvated by these water molecules, which creates a solvation cage around it, which kind of physically restricts it from getting in there, makes it much less nucleophilic to attack that position. And then lastly, because water is the solvent, there is just orders of magnitude more water in there than there is a Br minus, a bromine anion. So all things being equal, there's both same nucleophilic strength. There is just like orders of magnitude more water. So it's just the statistics are greatly favored running into a water molecule instead of a Br minus molecule, which leads us to our product right there. Now, if you have a symmetric molecule, it doesn't matter which side you pick, but remember, if you have an unsymmetric molecule, the alcohol forms at the most substituted position. It's more carbon-to-carbon addition of that alcohol, and it is anti-addition overall. And if you want more organic chemistry learning, hit that follow button.